Okay, so this is the audio review for Chapter 11, Multiple Methods. 2 or more approaches are better than 1. So in this chapter, we're going to talk about the logic of triangulation, composite measures, structural equation modeling, which is so interesting. No, I'm just kidding. We'll get into that. Replications that are using the same research strategy and those using different research strategies, and really just comparisons of different approaches and how they connect to each other. So starting off with the logic of triangulation. So what is triangulation? So starting off with the logic of triangulation, what is it? Well, it's just the use of multiple methods to address the same research question. So throughout lectures, we've looked at the strengths and weaknesses of different methods. So the whole point of triangulation is to overlap different methods that can reaffirm or verify the information that was found via another method. So we'll get more into what that means in a sec. So when you look at dissimilar methods, they're not likely to share the same weaknesses. Each method is different in its vantage point. Each has their own bias or limitations, but combining different approaches makes us more confident. When different methods find the same things, the strengths of one method offsets the weakness of the others. So this increases confidence when different methods produce the same results. Also, more than validating their findings, triangulation can be used to complement other information, such as quantitative information to further complement qualitative research. So when you're looking at multiple measures of the same concept, there's 2 ways to do this. First is by reducing the complexity of info by making an index, which we'll talk about in a minute. So you can determine the composite measures that are related in the way that the researcher hypothesized they are. And the second is to make a model that represents the relationships among concepts and measures of those concepts, and then test the model to see if it fits the data. So that's, through the construct validation, and, we'll get into that. Okay, so multiple measures are often combined into an index or a scale. It's difficult to measure a concept well on a single indicator or a single question. So not only do single indicators not capture the meaning of a concept completely, they may have bias. So if you combine different indicators, that tends to balance out the info, and that of course yields a more reliable measure. So both indexes and scales combine multiple indicators to create one single score. What is the difference though when it comes to these two? Well, a lot of people have used them interchangeably in research for a long time, but there are differences. So indexes combine indicators by adding or averaging without regard for how each item represents the underlying concept being measured, versus scales also combine indicators, but they do so to ensure unidimensionality or some other quality of the concept being measured. So there may be different things being measured, but they're combined in the scale. So the difference between an index and a scale is a bit fuzzy. Like I said, some people conducting research use the terms interchangeably, but there are a little bit different. Like I said, an index is an arbitrary combination of indicators where you add together the responses to the question without being specific about which contributes to the measure of the concept, while scales assign scores to patterns of responses. So constructing a scale assumes that concepts can be understood in terms of an underlying continuum that ranges from positive to negative. So when it comes to Gutman scaling, this is, of course, just creating a unidimensional scale. So a person's unit score on the scale reveals the unit's response pattern on all scale items. So the book example is that if you're trying to measure reading comprehension, then you would order the passages of reading in terms of difficulty by grade level. So people would be considered as pass or fail as they work through the readings. So then it would measure the reading, putting it in order. There's being 1, just flunking the entire thing; 2, passing at a 3rd grade reading level; 3, passing at all but college level; and 4, passing all the reading tests. So making one of these Gutman scales is no joke. It can be really complicated as you start with a bunch of things that are thought to measure a concept, and then you have to test the subsets like you would do with your coding, right? In order to see if it fits the expected responses of a Gutman scale. So the figure here is supposed to represent response patterns of a perfect Gutman scale. So it shows one that's working well, where the responses are patterned yes or no, and the totals for each person's responses you can obtain for the scale for that person's responses. So you can go through for each individual and you see, okay, for the first question, yes, 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 all the way down. Versus the next person, yes, except for the last one, right? So you can create these kind of, you can create a scale for that person's responses that would show you what their belief system is. So another example of this, I remember one I had to use in college when I was in grad school, was something they called the feminist attitude scale, which basically ranges from thinking that feminism is complete BS to having different understandings about feminism, meaning that we assume, because there's been such a media war against feminists for like 30 plus years, but anyway, that all feminists are something, right? But again, you can't really generalize with any group. So when it comes to feminists, there's Marxist feminists, there's radical feminists, there's multicultural feminists, there's, you know, what are called liberal feminists, or, you know, there's all these different groups that think that, you know, while they all agree to the idea that there's an oppressive aspect of society related to gender, what they think the focus should be is pretty different, right? Like liberal feminists think that you need to change the legal structure, because that's what liberal means. You just change the legal or societal governmental structure. So meaning, you know, instead of changing the way that representation works, we just basically amended the existing law to say that people of color could vote and then that women could vote, right? So anyway, that would be a liberal. So again, I'm getting way into the weeds here, but the idea is that in a scale like that, if you took that survey, you would be able to take someone's particular answers and figure out where they fit within the context of an you know, belief system, basically. So scales are really going to, you know, depending on how you answer those questions, that's going to reflect your ideology. So scales can really do this for an individual respondent. All right, so structural equation modeling, excitement. Okay, so it's a statistical technique that identifies possible relationships among a set of concepts and their indicators. So it's analyzing multiple measures simultaneously. The equation part of structural equation modeling is how the relationship is represented with a mathematical equation. So this provides information about the contribution of each indicator. So it sounds confusing because it kind of is, but there's an example in the chapter that tries to illustrate how this works from the study about mother love and self-esteem. So they use 6 indicators, you know, realizing that measurement is reactive, meaning, again, we've talked about this before, that measuring sometimes one indicator can influence another. So in this figure up at the top here from your book, the relationship between the indicators are seen visually. So you can see that certain things that are being measured kind of affect each other, right? So that's basically how these models work, is that you know, kind of set up what are the relationships between these different things. And this is why it's so complicated, because the more and more variables or issues you're looking at, the more complicated this becomes. So when it comes to replications using the same research strategy, you know, science is all about getting findings that can be replicated in other studies. So, you know, that way we can be sure that the findings that we have are relevant and not some sort of fluke or due to researcher bias or error or, you know, some issue with a specific study or a researcher. So if something is a fact, then if you do the research and so do I, we would come up with the same results. But when it comes to social science research, most of it is not focused on simply replication. A lot of it is really looking at, you know, differences in these things. So unless you're talking about experimental research methods, but replications are, you know, typically inherently dissimilar. You have a different person maybe taking a different approach or a look at different variables. So that in a way can really affect the, you know, similarities between replications and research, even when you're using the same research strategy. So oftentimes when you're looking at replications that are using the same strategy, this is just through experimental methods typically. And in these cases, the principal means of enhancing external validity is the whole reason why they do it. Because then you can see, if you're not sure about your external validity from your first research study or from your first experiment in this case, then you just do the experiment again. You bring in another group of people, you bring in another group of people, and the more times you do it and you keep coming up with these very similar results, the more valid that becomes. And then, of course, each study typically changes one or more elements of the research design, meaning, you're going to have different participants typically. you might have different manipulation of the independent variable or maybe the timing of the manipulation. And, so that just means you're going to measure the dependent variable differently. So even though you're using the same methods, it's really not going to be exactly the same, hence inherently dissimilar. When it comes to replications using different research strategies, there's so many possible combinations of research strategies. Each method we've talked about throughout the class has advantages and disadvantages. So if you want to know what people's opinions or feelings are, then surveys are good, but surveys aren't good at measuring what people actually do, right? Just what they say. But if you combined surveys with, or combined experiments with surveys, then you can compare what people say with what people actually do, which is going to make your results much more valid, right? So surveys can also be combined with qualitative research. So field research and in-depth interviews can really add depth and clarify survey results, right? When you can ask someone, well, why do you think that? Or what did you mean by that result, right? You can kind of probe further and really get at the inherent understandings of these, participants. So, these are just a couple examples of the way that mixed methods can be a helpful way to validate your research findings, or just limit the weaknesses of a single methodology that you might be using that has some sort of limitation to it because of the scope of the way that it works. So this is just a comparison of approaches kind of figure from your book. It shows which methods have strengths, weaknesses, and which are kind of in the middle of that spectrum. So you can see which kind of methods are appropriate to do in mixed method research, so you can limit weaknesses and increase strengths, right? So if you combine something that has, let's say, you have a strength and a weakness on the same line here, right? Control for investigator bias, right? Then maybe you would back up your survey, right here, with some existing data. And this could be just to even validate your findings or corroborate or just provide additional information, right? Because obviously this is not going to be reactive because it just exists already. So there's certain ways that you just have to understand how the methods work, what those strengths and limitations are, so that you can overlap them in a way that you eliminate or limit the weaknesses and really just enhance the strengths.